Bridget, hey, Jeff Carr here. It's Halloween at my house, as it is probably at most people's houses, so I apologize if there's a lot of screaming children running around my house that you can hear in the background. But I really loved your post, and there was something that really stuck out to me. I love that you said that data is the crust, and that really stuck with me. So I'm going to do a really horrible job of throwing out wild, probably unnecessary but totally connected analogies and an example here that just kind of resonated with me. I love that you called it the crust, because when the data doesn't come out right, kind of like when you're cooking like a pizza, and if you order, for example, thin crust, and that's what you're expecting and that's what you're wanting and that's what it's supposed to be, but it comes out either undercooked or overcooked, or if it comes out and you got extra risen crust, like super thick crust, and you're expecting thin crust, then it's going to skew how you feel and how you interpret that pizza and how the flavor for you as well. And then you talked about just think about the toppings on a pizza and how missing data can really mess up a research project. It can mess up your statistical analysis. And when you order a pizza and you are asking for pineapple, bell peppers, and black olives, because there are some crazy people out there like my wife who like that really disgusting combination. But if you order that and you don't get your pineapple, and that's your favorite part of it, and you don't get it, again, it's going to mess with your data. But having too little of it can also mess with the flavor. In the same way, having too little data or having little bits and pieces missing, you were expecting a lot of this, but not a lot of that, and it was reversed. So these types of things can all definitely impact the way you interpret data, your statistical analysis, and all of that. And then when you think about the assumptions, this is where I'm going to go really off script and really crazy. So bear with me here. I like the fact that this analogy works for me. It's how it helped me to understand the three different pieces: the normality, the linearity, and then that one that no one can say, homoscedasticity or something like that. So when you think about that normality, the normal distribution of the samples, the normal distribution of the data, if you don't have a normal distribution of toppings on your pizza, it's going to mess with your analysis of that pizza. It's going to mess with the way you interpret the flavors and whether or not you'll ever order it again, or if it meets the expectations that it needs to be a good pizza. And then when you think about linearity, the ability for one to connect to another in a straight line, I have to think of someone like my wife. She loves pineapple, bell peppers, and olives on her pizza. And I don't understand people who put fruit on their pizza, especially pineapple. That's an atrocity in my mind, but she likes it. But for me, those toppings don't connect. And it kind of helped me understand a little bit of linearity. I understand that some of your data doesn't always have to connect in a way if that's what you're trying to find out, if that's what you're trying to study. But that's how it helped resonate with me. And then the homoscedasticity, butchered it, I know. The idea of having too many toppings in one spot, or not enough toppings in one spot. When you think about a normal scatter of data, would be the same way as ordering a pizza with nothing but pepperoni. So a pepperoni pizza, but all of your pepperoni are stacked on one spot. That's going to be a problem for your experience with that pizza. And in the same way, not having that normal distribution, that normal scatter of data can be problematic for your study. So I appreciated the way that this kind of rocked my brain. I hope that made sense. And if it didn't, then it's Halloween. It's full moon. I apologize. All right. Have a good evening.